At AV&R, our mission is to humanize robotics. We decided to create this podcast series to help you demystify the world of robotics and discover what some of the brightest minds in the field are doing. Welcome to Robotics for All Podcasts by AV&R.
In this episode, we're excited to welcome Ben Williams, the Chief Operating Officer of Exyn Technologies. Besides acting as COO for Exyn, Ben is an active mentor for early-stage startups and entrepreneurs. He consults and speaks throughout the New York and Philadelphia startup scenes. At Exyn, they are an autonomous robotics company pioneering GPS-denied and infrastructureless autonomy for robotics, performing a variety of tasks. Ben walks us through why this is such a big deal for some of the more hazardous industries such as mining and construction. The drones and robots that Ben teams deploys are out in the field finding their own way around, getting some dangerous work done. Tune in for an enlightening conversation on the cutting edge of technology and the future of autonomous robotics. Hope everyone enjoys the show. Here we go. Hi, Ben. Thanks for joining me today.
Thanks. Happy to be here.
Great. First, Ben, let's start off. Tell me a little bit about yourself and Exyn Technologies.
Sure. So Exyn Technologies is an autonomous robotics company. We focus on the intersection of high accuracy rapid mapping and autonomous navigation for small scale robotic systems. And we're based in Philadelphia, Pennsylvania, venture-backed company, a spin out of the University of Pennsylvania. I personally am the Chief Operating Officer here and have been here for about 5 years. Broadly, my charter is productization, execution, and go-to-market. You can think of it as taking the core technologies and bringing them to bear in a product and customer-oriented setting.
Okay, great. So you said something there that piqued my interest. You said small-scale robotic systems. So when I think about a drone and the amount of area it can cover compared to what we do, that feels a little bit larger scale. So explain to me what your definition of small scale is.
Yeah, it probably depends on the audience, right?
Yeah,
so
sure.
In this case, what I mean by small scale robotic systems are systems that are smaller than a vehicle that could carry people. So this is mostly things that are quadruped robots like a Boston Dynamics Spot or Ghost Robotics, et cetera, or quadcopters, drones that are probably something you could carry as a person, but that could not, in fact, carry a person. But it's also not so small that it's going through a 1 centimeter square, or it's not something that's going in your bloodstream or something. It's, I guess, in the grand scheme of things, it's a mid-scale robot.
Okay, so you're not talking about the amount of area you're covering, but the size of the robot itself.
Yeah.
Okay. Now, what type of payloads do you typically get into with your solutions?
So a system that goes on a lot of different kinds of things. We can be guiding any type of system, and therefore all kinds of different payloads can go on top of it. Core to the baseline approach is that we do sensor fusion of a lot of different things. So we can roll in the core geometric models that are captured by the mapping. You can also overlay that with visual or infrared photography or video. You can integrate things like RFID for logistics. You can do gas sensing, radiation sensing, temperature sensing. You can get this really rich data set covering an environment, which is the whole purpose of these systems in a lot of cases, is to do more faster and easier than a person could carrying a bunch of devices and trying to measure things.
Sure. And I, as I was going through your website, you talked a lot about mining. So I'm guessing that's a pretty dangerous. There was one really interesting article, and I'm jumping in our list of topics here, but there's one interesting article about you guys were brought in to look at some historical mines. And so what was the purpose of that? Like, what was the company trying to achieve by looking at some of these old mines? Is it from just a curiosity standpoint, or what was going on?
Yeah, so in a lot of those cases, mines that haven't been worked in a long time, may have been shut down for economic reasons or safety reasons, or 100 different things. But they often look at reopening them in the future, and to reopen them if they haven't been operating in a while, they haven't been checked or verified safe. There's a lot of work to go through to explore the mine, map it, figure out what you have to do to update the safety structure. Is it even possible or economical to do it? And so in a lot of those cases where you're investigating old workings or old mines, you need to basically put a system in there before a person goes in, and you don't know what the environment is going to look like. So you might just set an explore volume and say, look, just find whatever you can in there, give me the best model and any visual insight you can as well. And that can be the baseline for them going in and setting up, safe entry and inspection, and begin planning for whatever it is they want to do with it, whether it's to reopen it as a mine or open it as a tourist attraction or use it for some other industrial purpose like storage. There's a lot of reasons to reopen some of those facilities.
Right, right. And I'm imagining, inside a mine, there's not many external information you get to go off of, right? So years ago, I used to go to a vision conference in Boston, and there was a working group where you would tell all stories about your worst machine vision implementations, your best fails.
Yeah.
And back then, one of the conversations switched over to a DARPA challenge, where some guys were trying to figure out how to map mines with no GPS signal data.
Yeah.
And one of your claims to fame was GPS denied environments.
Yeah.
So it sounds like you guys figured it out. Back then I was thinking, wow, that's a dream. That's a tough problem to solve. So how did you get into that kind of niche, and maybe explain what is a GPS denied environment and why it's important?
Absolutely. So we got our start doing that because we were building an odometry-based system, and odometry is basically a way of calculating a position in an environment, or what's called localization. And it basically is tracking features in the environment using a sensor. When those features move, if they all move kind of at the same time, then the system guesses I must be moving because all the features around me are moving. And what that does for you is that it gives you a sense for where you are on a local frame, relative to where you just were. It tells you like small changes in movement, which is not the same as GPS, because that gives you a global frame of reference, like where am I in the world, as well as where am I moving locally. But it's a starting point. And so using this sort of core technology, you can actually start to establish where you are moving over a slightly larger area. And that in turn means that you can navigate in these local environments without the need for a GPS or equivalent. And so we first started applying this to commercial mining, because those are underground and you don't get GPS at all in most of those environments. And so that was a critical need they had, and they drew us in, basically said, look, it seems like you can solve this, let's get moving. And we have our first partnerships there began 5 years ago, and we've been operating autonomously and in GPS denied for all of that time. And GPS denied in those environments is really obvious, because you can't have it at all. You don't start with it, you don't end with it, you never have it. Where it gets really interesting is in places where you might have it sometimes, but you can't necessarily count on it. So think of, if you're flying outside or driving outside, you mostly have GPS. But if you are going next to a lot of tall buildings or underneath a large bridge or in a parking garage, you might lose GPS, here and there throughout it. And so what that means is that if you're depending on GPS, you might be stuck, or you might not be able to tell where you're going while you have lost signal. So having a system that is resilient to the loss of GPS is a little bit different than totally GPS denied, but still really important. And especially for an autonomous system where there's no human in the loop there to say, well, I still know where I'm going because I can look around and see, I don't need the GPS every second. In this case, you have to have a system that is resilient to the loss of signal so that it can continue navigating, continue performing its mission, so that eventually when it gets GPS back, it can relocalize on the global frame of reference, but it's still able to navigate and perform its mission in the interim.
Right. So a lot of these missions you're doing are gathering data of, let's say, unexplored environments. So what are the parameters? I'm imagining, so know you're an environment and you say, okay, I want you to go here, then here, and you set up a route, and maybe there's some things it does in between. in your case, when you don't know very much about the environment,
Right.
you just set your drone loose and
Yeah.
it goes for a certain period of time. Walk us through how
So
that
I think
works.
that is probably the most interesting and unique thing about our system, and the autonomy industry in general is trying to get to these kind of levels, which is being able to remove specific path planning or specific mission planning from the humans table and instead having the robot do it. And so you instead as a human say, I just want to do this high level objective, which is explore this building or explore this area underground that may or may not have a cave or a mine or a tunnel. If there is, explore it. If there's not, then just come back home. And so creating a high level objective, and then the system self-defines safe navigation corridors, intermediate objectives and milestones, and sort of success criteria along the way. That creates a wholly different type of mission planning, which means that you don't have to do it as a human, and it can react and respond to changes or new information in that environment all along the way, which is, that's the target for an autonomous system, and it's
Right.
a great sequence for us.
Right. So there's 6 levels of autonomy that kind of have been sketched out. Where do you guys fit yourself into the level of autonomy that you can achieve?
So it seems like every company sort of comes up with their own. We've tried to standardize as much as we could. We went off of the SAE standards for self-driving cars. We worked with IEEE and some universities to try and have sort of a vetted standard for us. So with that in context, we have an article published a couple of years ago that gives more detail, but the short version is we sit at what we call level 4 autonomy. And level 4, in this case, we are defining as able to execute a high-level mission objective without interaction from a person to kind of interpret pieces along the way. And so what that practically means from our perspective is that the system is self-contained. And once you give it the mission objective, you can actually turn off your tablet, you can turn off the radio, and the system will complete its own mission without any input or changes in parameters from the tablet, which in the drone world is called a ground control station. But the whole idea is that you're sort of decoupling that a little bit, and that system is self-operating, and you are breaking that link between single operator and single drone as kind of a required linkage.
Wow, that's pretty cool. Now, do you think this is a tougher solution space than, let's say, self-driving cars when you're dealing with drones, or would you say that cars are a tougher solution space for autonomy?
You probably get in endless arguments about this.
Yeah.
There's things that are easier and then things that are harder. On the thing that's easier about cars is that you are generally in a structured environment. You can usually make some assumptions that you'll probably have GPS, you're probably going to have lines on the road. There are mostly what you're worrying about are people or bikes or cars or trucks. And there's, you can do some classification and machine learning stuff that give you a leg up there. That also operates at a much faster speed. So you need, highway speeds, you need better, faster processing than you do for, a slower moving robot. You also need to be able to respond at very high speed when someone is coming at you. So there might be a differential speed of 120 miles an hour plus. So there's issues to work through there as well. For the aerial robotics side, you can't depend on having an accurate map. You can't depend on any kind of rule set. There could be things coming from 360 degrees and up and down and every direction. And so you need a broader sort of sensing, but you also have freedom to move in 3 dimensions, which you don't on a car on a road. You have 2 dimensions only. So there's other interesting things. It's like a different way of thinking about the autonomy. And we specifically work in unstructured environments where you're working at slower speed, but it's much more complex. And so you need to be calculating and recalculating safe navigation corridors continuously, and you don't necessarily know what's around the next corner, and you don't have a pre-made map in a lot of cases. So it's a different beast. I think you could probably argue either one is harder, but probably the folks that know them best would say that the one that they work on is the hardest.
Of course, of course. Now, what are typical speeds that your robots work at?
It depends. For some of the mining world, we artificially restrict the speed because you don't need to do really big captures, and a lot of the end customers prefer denser data sets. So flying slower gives you more information. So we artificially cap it at 2 meters per second or 2.5 meters per second. We've demonstrated 5, 10, 15 meters per second in different environments. So you can get going pretty fast. But in most of the cases we're looking for, you're not trying to go that fast because you're not trying to cover a huge area. You're trying to get highly dense, accurate information for areas of interest, right? And so those are often places that either people can't get to or are difficult or not economical to get to. And so you are often covering very specific environments with these types of systems.
Right. Now, the one intriguing thing, so everything I'm not in the world of drones and unplanned missions and stuff like that. Everything we do is pre-planned. But on your website, you've got a number of distributors and partners that are there, using these systems to solve problems. So I find that interesting because you were able to make this complicated technology at least simple enough that you can have a couple partners, right?
Yeah.
So what type of skill do you need to operate one of these systems?
So we have purposefully made the system easy enough to operate that anyone that can use a smartphone can basically operate the system. That is not the same thing as saying an expert operator can be someone who has no knowledge about the space. We do oftentimes 1 or 2 days of training for new operators to teach them all the edge cases and how to optimize usage. But we've done plenty of demonstrations where we will show people how to plan a mission, hand them the tablet, and within 5 minutes, they've flown their first autonomous mission. And so not super complicated to get started. To become a real power user, takes a little bit of time and experience to learn sort of the edge cases. But the whole point of these systems is to remove the cognitive load from humans and put it onto the robot. And so if it's really complicated to start off with, then we haven't done our job in the first place.
Right. And typically when customers come to you, are they buying a system or are they asking for you guys to help them out map an area or is it a mix of both?
It's definitely a mix. We do sometimes do services work where we'll go and help people get a specific map if they don't have a use case where they're going to use it regularly. We like to help out where we can. We also have partners that are part-time distributors, part-time services groups, and we try and support them to do a lot of this work as well. Our core is as a product company, so we're not really built around the services model. So we mostly try and build the systems that people can use to support their businesses, whatever that looks like. So we find the system used quite a bit in services and contract work, as well as internal to companies that have their own operators that are doing the flights or the captures themselves as well.
Yeah. Okay. Now we talked about mining. What other industries are big for you guys? Like what are like established ones? And then I'm also curious what emerging industries do you see coming?
Yeah, so I mean, we do a fair amount of work in the government space, mostly around similar use cases where you're capturing sort of inaccessible data or difficult to access data. You can think onboard ships or critical infrastructure, bases, bridges, tunnels, et cetera. A lot of the stuff that you can think of as being sort of in the combined civil, federal, and DoD space. That kind of broad coverage we do a lot of work in, and then that extends actually into one of our newer markets, which is the sort of the broad survey and geospatial. And this is a little bit different than the geospatial of like pure satellite, where you're very high altitude capturing sort of 2D or 2.5D maps. Instead, this is, think of the 5 feet to 50 feet or 5 feet to 500 feet level of three-dimensional data that is centimeter accuracy, easily updated, rapid capture, where you're then integrating it into these global models. And so there's a ton of interest around infrastructure, especially operations and planning, being able to go and capture the actual as-built environment so that you can then put it into a VR environment or, a game engine, modeling environment where you're able to figure out how much clearance there is underneath a bridge, or, for a large truck going around a curve, what is the actual clearance for you in that space, not going off of 50-year-old, construction drawings, but going and seeing what's there today. Is a huge benefit operationally. So there's a lot of really interesting use cases that, in a lot of cases, wouldn't have been possible 5 years ago. But then you get a mapper in your hand, you can just capture these amazing data sets quickly.
Yeah, and I guess it's the volume of data as opposed to coming out with some of the more manual kind of surveying equipment.
Right.
You get much higher fidelity, I'm imagining.
Well, a lot of times it's about being able to capture it quickly enough and economically enough. Yeah. Like if you have enough guys out there with tripod scanners, you would eventually get the data that you need, but you're gathering it 10 times faster with a mobile mapper or an autonomous system than you are with sort of a stationary system. And some of the stationary systems end up being higher accuracy than we can get because you're sitting in a specific place and they're very high precision lasers. And there's a category where those are still the gold standard and will be, because we're not trying to tackle all of those use cases, but especially for places where people are just not even bothering to gather the data because it would take too long or it would cost too much. Yeah, okay. Then all of a sudden, a single person with one of these systems can go capture all of that data that you need in an afternoon, which otherwise would take a team of 5 a whole week. And that is an order of magnitude increase in speed and the ability to capture data you probably just wouldn't have bothered with before.
Right. I can see the city of Montreal being interested in counting construction cones. I mean, we always make jokes that as soon as the snow melts, the construction crews come out and they just move cones around until the snow comes back. Yep. So, I'm sure there's a good inventory count that they could use help with.
Yep.
So over the next 4 to 5 years, what do you see as important for your industry? If there was some breakthroughs, what are the big challenges that you guys have of being able to unlock some challenging applications?
Yeah, I mean, a lot of the hardest work that's going to come over the next few years is going to be the least sexy, and it's going to be under the hood stuff where, there's been a ton of advancement in new capabilities and new features and functionality. And oftentimes when you have an industry come out with a bunch of crazy new features, they'll work, with some asterisks. It'll work given specific conditions or, a perfect environment or a really capable user. And the work to grow adoption of those technologies is usually, 5 or 10 years of cranking through user experience improvements, edge case coverage, reliability, scalability, and cost. And so we're kind of in the middle of that sequence right now where, we've been spending the last couple of years really focused on just making the core product better and making the systems last longer and, work every time. And so a lot of that work is really what's going to improve the end user experience the most, I think, over the next few years. But what is going to happen, I think, in the next 2 to 3 years is you're going to see much broader adoption of autonomous systems in industrial environments because of that work that's going to make them more reliable. And, people have already seen the flashy side of it. So everyone is kind of interested and they're doing little tests here and there. Yeah. And now we're finally starting to see the light bulbs go off when they've done some testing and they go, oh, you know what? This actually is good enough for us that we're willing to buy 3 more or 5 more or 10 more and start scaling across an enterprise. So I think you're going to see a lot more adoption in this industry in general for these sort of mobile autonomous systems, just digitizing their environments for especially industrial and enterprise clients.
Will be a more common tool in the toolbox, another Milwaukee tool that that you see on the job site.
Yep.
Yeah. One of the applications that captured my imagination when one of the latest rovers went onto Mars, and it had a drone on it.
Yeah.
And they started, flying mini missions to on Mars itself, and I that was,
it's amazing.
I had never thought about it. but a lot of much smarter people did, and they made it happen, right?
Yeah.
What are some of the most interesting applications that you see are out there that if you had more time,
Yeah.
we have to focus on, what
Right.
what pays the bills and
Yeah.
what people need right now, but what are some of the more interesting or exotic applications you've seen out there?
Yeah, I mean, there's so many really interesting ones actually happening now because of the cost curve is coming down and the capability curve is going up, and you're getting a lot of interesting new crossovers for applicability. So I think there's going to be some fascinating stuff happening with fully unmanned industrial zones where there are, an underground mine where there are no people underground. There's a construction site where there are no people in a whole section of it. There's going to be foundries or factories or, fill in the blank warehouses that people have been removed from entirely. Or there's the most dangerous zones are going to be completely sealed off from people.
Right.
The inside of nuclear plants, those kind of there's all kinds of options and opportunities where, people don't really want to be in the most dangerous environments anyway. A lot of those industries are having trouble staffing those jobs. And so they can't even operate without getting robots involved in the first place. So it ends up being this massive productivity boost. So, then that extends into space travel work. That's always been the place where unmanned has the most, opportunistic place, because when you have an unmanned system in space, you don't need to think about oxygen or safety systems or, any of the food or waste or whatever. Your efficiency goes way up. So, think of automated docking systems, unmanned mining on asteroids. There's all this crazy stuff that you can start getting into now that you have systems that are able to stand on their own and be fully autonomous.
Right. Oh, that's really interesting. So in an industrial environment where, let's say it's an unmanned underground mine, what type of safety requirements are put around your drone? Is it, what is the order of priority that, for a robotics system in a manufacturing environment, the people around the system come first, right? And then you put all the safeguards in to make sure they can't put their hand in, the robot can't get its arm out and stuff like that. And everything revolves around that.
Right.
What's your order of priorities when looking at an industrial setting?
I mean, I think it's the same, right? Those priorities are consistent across any of the industrial customers. So especially, we're working not predominantly, but we're working in significant volume in Western Europe and Northern Europe and US, Canada, Mexico, et cetera. So, those are places with pretty strict rules and regulations around safety and industrial policy. And so those are how we design the system anyway, no matter where it is in the world. And so it's designed specifically with safety in mind. We have, safety boundaries around the system so that it doesn't get too close to people or walls or wires or any of these things. And that's something that you can adjust if you really want to, but we ship it with a pretty conservative approach towards safety, because as you say, the priority is people first. And once you get people comfortable with the usability and how it can help them, then they start using it more. So it's a self-reinforcing thing as well. It gets them to use it more.
So are you guys detecting the types of objects that are in the environment? Like, if a person walks in, are you looking for if there's a person in the environment?
We've done some integrations like that where you do sort of people classification and you can sort of take action on it. But mostly we do environmental classification where you're understanding elements in the environment and what that means to safety of flight. So, removing yourself from dust or fog or rapid temperature transients, you want to get out of that zone because it can mean something for safety of flight. So there's a lot of these little edge cases that are basically environmental impacts that you want the system to identify, classify, and then take action on, regardless of whether there's a human in the loop or not. And so that's been a bigger portion of our focus. Most of the environments we operate in, there are people present, but you try not to operate where people are like right next to robotic systems most of the time.
Right. So any dangerous area that, or GPS denied area that people need some data of, maybe they want to do something in that environment, change the environment, but that's where you guys fit in very well.
That's right.
Am I capturing that right?
Yeah, no, that's a great way to put it.
Yeah. Okay. Now, besides, making sure drones know where they're going and getting big amounts of data from these environments, what do you like to do in your spare time?
Well, I've got a 3 and a 5-year-old, so my time is mostly spent keeping them from smashing dishes on the floor and pouring yogurt behind the couch and all that kind of stuff. But yeah, beyond that, I used to do a lot of mountaineering, and I played rugby for a long time. It was really fun. I do a lot of active mentorship as well for the startup community in New York and Philadelphia. So yeah, that's pretty much how I spend my time, I think.
Okay, great. Well, Ben, it's been really fascinating to hear about Exyn Technologies and what you guys are up to. Any last things that you'd like to mention?
No, I appreciate you having me on the podcast here. It's been really fun.
Yeah, it'd be great to have you back in a little while to hear what's new with you guys and hear if you got into some really fascinating applications.
Absolutely, we got a lot of good stuff coming up. We'll have to get back on soon.
Right on. Appreciate it, Ben.
Absolutely.
So this concludes the episode of Robotics for All podcast by AV&R. If you don't want to miss another single episode, don't forget to subscribe to our show in your favorite podcast app. Thank you very much, everyone, and we'll talk again soon.